What's the difference between procedural programming and object-oriented programming? The languages aren't really the difference. While some languages are better at object-oriented programming practices and procedures than others, it has more to do with your style on which you're coding. And we're going to take a look at two different examples of where I've written the same program in the same language that does the same thing in the same order, but they're just written, one is written in procedural format and one is written in object-oriented programming format. So why is there a difference, and why is it good to be aware of the differences? The old school style is the procedural. That's the one that we started out with before we had object-oriented. Then we created object-oriented that allows things to have different modifiers, most commonly private and public. Private is accessible only within a private method or function or member, rather. Any type of member, any type of part of that object that is private is only accessible to code that is running within the object. If you're dealing with something that's public, you're dealing with something that can then be referenced from outside the object as well. And then there are some other languages have some other ones, and they're different. So look up the documentation on the language that you're working with, but sometimes they have different rules on where certain things can be accessed in different places. Some of the other concepts dealing with these public members are the different types of members that you can have on a public object. We've also got we got fields. Fields are, I'm going to use an example on here, which is going to be an IP address. We're going to have an object that is an IP address. Now, a field is almost always a public method. I'm sorry, not a public method. It's a public variable. A field, it would be a public variable. It would be something that is, the downside with it is that you're not validating it coming in, and you're not being notified about it coming in, which means any code which you're writing within that object that is using that public field, you want to check for any changes and validate it for what you expect to be there before any time you access it. An example of what we would use for an IP address for fields might be the individual numbers. And IP address is a network address that's made up of 4 small numbers separated by dots. Those numbers are ranging between 0 and 255. So in this case, on my field, unless I need to invalidate certain numbers, I need it to be a certain network address that's valid for a certain domain, then I can pretty well, if I'm just after the numeric format to be correct, I can just make sure that my field is in the type, if my language supports that, is in the type of whatever it needs to be for it to support that that data. So that way I don't have to worry about the validation. The program will do, the language itself will do that validation. But you might not have that luxury. You might have certain numbers that are still invalid, so you still might need to do some further validation. Now, property is something, now fields are the most commonly supported across most languages. Fields are the most commonly supported member of an object, followed by methods. The others, the properties, the constructors, the destructors, and all the other stuff is not as it's not as common. But field is most common, closely followed by method. Now, a property, you can make up for that with a method. Certain languages, they do that. They just write methods to make up for the properties not being available. But a property is designed to kind of be like a field. It's supposed to act like a field, but you can also add arguments to it, and it is able, on the inside of that object, you're able to write code that is able to notify and validate for changes to that, or even construct the information going out. So while the fields are the individual numeric values for each individual number between the dots, I could create a property that is the string value of that IP address. So as I get it in, I'm going to make sure that it is numeric. I'm going to make sure that it has the right number of dots, whatever I need to check for, and I'm going to parse that and put those into those numeric fields. Whenever I pull that information out, whenever I want to get that IP address, then I can take that, I can take all those numeric fields and concate them with dots and to return that as a string. And I could also have additional values that I would send to it, making sure that, I don't know what you would actually put as far as an argument to a property, but it can also support arguments. So I could say, hey, I want to do something fancy with this. But yeah, I don't know what you do with an IP address on there. But methods, on the other hand, also support arguments, and we'll use that. They can have arguments passed to them. They can't have a value assigned to a method, but they can have values passed to them in the form of arguments, and then they can also return a value. That's usually in the form of a public function is what makes a method. In the case of what I was saying about using a method in case of a property, that would be a method that would return the value, get value, returns the value, and then set value, and then you would pass that new value on as an argument, and it would return nothing. That's the common practice for using methods in place of properties. And in this case, we could, for our IP address, we could use that for, ping, for example, on that network address, where we could have an argument that says how many times do we want it to ping. We could then return how many packets are dropped, or how fast was the ping, what was the latency rate, average latency or maximum latency, whatever it be that we want to return, or maybe even an array of everything. But methods are basically being able to tell that object to go do something. Constructors, they're something that can run when that object is created. So you can run something and set it up. You can set initial values, whatever you want to do. So you might have a constructor on your IP address that can allow you to set it for a default loopback of 127.0.0.1, or you might be able to send it the numeric fields as 4 different individual numbers, or as a string representation, whatever you choose to do on that constructor. But it can initially set everything up. And then the destructor is for whenever you are shutting that object down, to be able to clean it up and stop everything that needs to be done. It's the cleanup routine. So it would be to stop any active pinging, free up any of the memory for for those IP addresses, anything like that. The destructor is able to do those things. Another thing too that I don't have on this list are it's because they aren't called the same thing in every language where they exist. Different languages call it different. Some of them it's callbacks, sometimes it's signals, sometimes it's delegates, sometimes it's events. But it would be a way of the object, and they work differently as well. and it's the way of the object being able to notify anything else that cares about something happening. Like you could put an IP address changed, whatever that was, event signal callback, and then that could be sent to whatever cares to listen to whatever's happening. So you can have another object that's monitoring that IP address, or maybe you have a different event that's been given whenever a ping is returned or something like that. Maybe you want to return it by it. But yeah, that's another thing that you can do with an object as well, is you can have other objects listen to that, or you can pass reference those objects, pass references to functions that are supposed to, that's a callback routine. Callback or delegate, where you pass a reference to a function and then that function is called. But those are things that can be done. But now let's get into our examples between the two different styles. So these are the add-ons that we can add to object-oriented programming. But now we're going to take a look at the two different styles and exactly how does this work. So these are both the same. This is procedural programming, and this is object-oriented programming. These are both written in Python. Both of these are Pythons. Both of these are GTK. So they're both going to import the GTK. They both have the in-program function that's called for whenever we want to close out of our program. And they both call the GTK main down here at the end. Where they differ is with everything in between. And you'll notice too, we've got 12 lines on the new hotness of programming, the object-oriented programming. And on the old style, we've got 9 lines. What's up with that? We just made our programs longer? Yeah, they've done a lot of that lately. However, you have a lot more control with the object-oriented programming. And this is a very short program. If I was going to write this program and actually use it, if I was going to choose which way I was going to do this, I would use the procedural for this program. If I'm writing a bigger program that has a whole bunch of other functionality that's doing everything else, that I'm going to want to use the object-oriented, because it's easier to expand on. It's easier to debug. I can debug individual objects and then just debug the linkages between the objects and the other code that calls that and starts all that. So this is bigger because, yes, it's part of, but it's doing the same thing. But yeah, this would be easier to expand on. So what did we do? What is the procedure beyond this? So we've created a function in both. We've gone down here. We started. But how are these the exact same program? This one, what does it do next? This does not run until it's called. Functions are just, they're created and they're a reference in memory. They're called once they're run once they're called. So it imports all the GTK stuff, and then it's going to create a window and create a reference. It's just creating a standard window. And then I can say, I set my title. I set it up to where it's got that. This is to connect the destroy signal. Once I exit out of that window, it's going to allow it to close out of the main loop and therefore proceed beyond this, which there's nothing beyond here. It then closes out of the program. As it's going to hang here. This is going to run in GTK. Which, yeah, that'd be easier to explain in just a little bit. But this is all setting everything up for GTK to run. So I've imported it. I'm setting it up, creating the window, setting the title, setting up my leaving event, preparing that so that way once that X is clicked, this up here will be hit. Then I'm going to just set my size. And then I'm going to show, I'm going to tell it that that window gets shown. And I'm starting my GTK loop, which checks for all of the sizing and all that on the window and checks to see if anything's been clicked, all that, does all of the GUI stuff. So everything else that it's running is based on the GTK loop. It's stuck in that loop until it's been told to quit. And that's what this does. Once it's had part of that loop is that window's been exited, it is then going to call this function that tells it, okay, exit out of that loop, which means now this function can then return. There's no more lines in the program then exits. Alright, so the bottom line though that we really need to understand on this is we've got these 5 things that are different, because all of that's going to be the same on both. The class does not run, it's the same as a function. It will not run until it's created and called. So once it's created, then your constructor is run. So we're first creating the window. And over here, this is why we have 12 lines as opposed to 9. It's made up of these 3 and this one down here. Create that window. Those 4 lines are used to create that one object. So what I'm doing here is I'm defining a class that is extending the window class. Usually with object-oriented programming, a lot of times you will create and work inside of classes of a library. And that's what I did here. I'm creating my window. That was, I'm creating a GTK window, but now I've extended on that. So that also allows me to kind of create my own windows in a way. And then this is the constructor for Python, this int. And all these functions here, they gotta have a reference to themselves. The first argument of any of these, the first argument of any function within a class is the class itself. It always passes the class there. And now we're going to come on in and we are going to call, this is the parent's constructor. We need to call that. So we have all of this. So we've gone inside and we've actually created a class. Now we're working within a class that is within a class. So that way, once we create this window down here, it is creating its parent. This has already been defined, and then it creates that. So it just defines itself, and then it's creating, and now we've started. So we've created the window. That's what we've done. Now, we set the title, just like we did over here. Exact same title, exact same destroy, exact same default size set, exact same show all. This is all the same. It's just now being set from within that class. So now if I want to create 5 different windows, I just create 5 different classes. I can just copy this down here 5 different times and I've created 5 different windows. Procedural, I'd need to create like a function that would create those windows to be able to create that similar effect. So yeah, these guys here are all created down here. So once this is run, this creates the constructor, and so this is all of these guys, is that 5 lines of code from the other one. These 5 lines. And then GTK start. So we run those 5 lines within this line, and we started it. So these are the exact same programs, how they work. Let's just take a look here at what they look like, and we'll see. They're the same thing. This is procedural. And this is object-oriented. Same program, same thing. 2 different styles of doing the same thing. Thank you for watching.